The times of times J90 asked in the comments on the previous video whether adding voice design and base TTS follows the same process. So I figured this was a good opportunity to show how I implement new features using a structured workflow. Let's look at the structured workflow together. Research context setup, prompting for the implementation plan, review implementation plan, implementation, and finally testing and validation. Let's open a new document and call it technical specification.md. We save it in the root of our project. Here we take important notes during the research phase. Let's start by opening the Qwen3-TTS GitHub repository and taking another look at the README file. It includes code examples covering voice cloning, custom voice, and voice design. We download and trim the README-MD file down to only the most relevant information, removing anything that is not relevant. Let's save it as Qwen3-TTS readme.md in the root of our project. As you can see, all irrelevant parts have been removed from the file, leaving only the code samples and short model descriptions written by the authors of the Qwen3-TTS repository. After reading the Qwen3-TTS readme, we can see that there are 3 different models that our backend needs to handle, and we need to think about VRAM usage. My system has 32 GB of VRAM, so I can load all models on startup and keep them in VRAM. But this is not always the case for everyone. So we should implement a model manager that can load and unload models from VRAM as needed. The model manager should be responsible for the following: keeping track of which model is currently loaded, unloading the current model when switching if the request requires another model, and loading the requested model on demand. Since we already have a fast API powered Python backend with working voice cloning implementation, we don't start over. Instead, we use it as a basis and tell the LLM to plan the implementation of the new features based on the existing code. Now we write the prompt. It's important to give the LLM as much context as possible. We include the technical specification document, the Qwen3-TTS readme file, and the existing api.py file as context. We also instruct it to plan a refactor of the existing code while planning the implementation of the new features. As you can see, the LLM understands the task, and the feedback it gives in the thinking phase tells us it's heading in the right direction. With clear instructions and proper context in place, this implementation should be pretty straightforward. The LLM has finished the planning phase, and now it's our turn to review the plan and make sure everything lines up with what we want. As you can see, even a relatively small feature extension like the one we're building here still requires some planning and research. For planning tasks, I almost always use high-end models like Claude Opus 4.5 or 4.6 or something in that class. They're not always the fastest, but they're extremely good at structuring complex work. By forcing a stronger model together and organize all the relevant information into a solid implementation plan, we can then hand that plan off to a lighter model like Gemini 3 Pro and be fairly confident it will successfully handle the actual implementation. Now we sit back and let the LLM implement the new features in api.py and write a readme.md documenting all the endpoints and how to use them. Since we're updating the frontend in this session and the LLM still has a fresh understanding of the backend, we can now prompt it to analyze the frontend code and update it to match the new backend using its own readme.md as context. From here, you know the drill. The LLM will now plan the implementation, we review the plan, and once approved, we let it implement the changes and then move on to testing. So as you can see, the frontend has evolved a bit. Let's try cloning. I'll record my voice for a few seconds. This is a test recording to test out voice cloning in the new backend and frontend. Okay, now let's type something out. Put the money in the bag. Subscribe or else. Okay, that's voice cloning done. Let's try custom voice next. You can see it switching AI models. Let's check here as well. You can see model type.customVoice loaded successfully. Looks good. Okay, here we have some speakers. Let's try Serena. We'll try something random, like making her sad. And let's use this text: I slipped on the floor and hurt my knee.
I slipped on the floor and hurt my knee.
And hurt me knee. Okay. A little happy accident there. Let's try happy, overexcited, mentally unstable.
I slipped on the floor and hurt my knee.
Okay, let's try without mentally unstable.
I slipped on the floor and hurt my knee.
Okay, let's try to make her angry.
I slipped on the floor and hurt my knee.
Let's try Vivian's voice and do something different, like whispering.
Hush! They can hear us if you're not quiet.
That's actually quite good. Wow.
Hush! They can hear us if you're not quiet.
Alright. Let's try Eric on this one.
Hush! They can hear us if you are not quiet.
Okay, nice. Let's try making him yell it.
Hush! They can hear us if you are not quiet.
Let's see if we can make him go completely mental.
Put the money in the bag, you silly goose!
Let's see if we can make it even funnier.
Put the money in the bag, you silly go! Ah! Ah! Wahoo!
Okay, let's try voice design. Let's give Qwen3 something tricky, like a little girl who struggles to pronounce the letter S. And let's try a sentence with lots of S sounds in it.
Soccer mom seems so stubbed. Soccer moms seem so stupid.
Let's just copy and paste this into the text-to-speech field.
Next generation zero-shot voice cloning and synthesis using 1.7B parameter transformer models.
Okay, that wraps up this tutorial. Hope you enjoyed it, and I'll see you in the next one. Bye!